we created, and thereafter we'll proceed for the next thing. Okay, everyone, if gets muted, then it will be very
Yeah, it's
okay. So you can see what we did. Let me give a quick revision. Okay, we understood how can we create a model. Okay, and thereafter this is we created a model. Simple process that I explained earlier. Only the data is changed and then model is created. Okay, and thereafter we are getting a model with accuracy of around 93 to 95%. That is 93% in training and 95% in testing. Okay, on unknown data. On training data it is 93% accurate. On unknown data it is 95% accurate. That means it's very fine. Okay, that means this model we can trust. Okay, it is not a overfit model. It is throwing it is giving a accuracy label on known as well as as well as on unknown value, almost very close. Okay, so we can trust this model, right? Now we have to discuss the predictions. How can we predict? Okay, so for prediction we need a value, isn't it? So let's consider a value x test underscore n. We have to consider, we can't consider x test because the training has been made on normalized data, right? So data needs to be normalized first and thereafter it can be used. Okay, suppose we are considering x test 67. Okay, this is your input value. Okay, so you can see it is a normal, it is normal value. Okay, it is a normal data. Okay, it is what, it's a normal data, but again this data can't be used for prediction. Okay, what we have to do, we have to normalize. For example, let me use it for the prediction. So for using it for the prediction, what I will do, I will use model dot predict. Okay, dot predict, and model is what, the neural network model that is created, and I am predicting it. Okay, so what I'm getting error related to say. Okay, so what is a error related to say? For example, if you see x train underscore n on which training is made dot say. Okay, it is having a shape of excuse me, 60,000 cross 784, right? So it's a two-dimensional data. And what is the shape of the data that which we are using for the prediction? The data that which we are using for the prediction is having a shape of 784. It's a single dimension. That means there is a challenge. Okay, that means these two shapes are not same. Well, the training data, for training we use two dimension, for prediction I am using single dimension, so obviously it will not work out. Correct. For prediction also at least two dimension is required. So how can we convert this thing into two dimension? We can convert this thing in two dimension, like it is just single sample. So first coordinate is representing sample, so just use reshape. Okay, first coordinate is representing sample, so 1. Second coordinate is representing number of features, so 784. Better. Okay, so now it is done. Okay, okay, so now you can see the predictions. Why there are so many predictions? Why is it not like single prediction? Because there are 10 neurons, right? At the output we were having 10 neurons, and that's why we are getting the prediction, we are getting the value of each neuron. Okay, so the 67th value or 67th feature is very close to 0, 1, 2. Please mute yourself. If you have to ask something, you can ask. I'll give you time. Just but for now, please mute it. Please everyone check that are you muted or not. Okay. So the feature at location 67 is very close to 0, 1, 2, 3, and 4. Okay. That means what is prediction? The prediction is np dot arg max. That means argument maximum of this whole thing. This is the prediction. Correct. NP is not defined. That's better. We can import the NP as numpy. Done. So prediction is what, 4. And what is your actual label? Actual label is present in y test. This is your actual label. Y test 67. Okay. So actual label is what, 0, 1, 2, 3, 4. Okay. NP dot arg max. So actual level is also 4. Okay, so over here prediction is correct, right? Let me change the location. 7, it is 9. For 7 the prediction is what? 9. And for 7 actual level is what? 9. Okay, so predictions are making, that means my model is working good with a normal value as well. In case if it will not work good, we have to normalize the value and then we have to use it. Okay, in case if it will not work, what we have to do? We have to normalize it first, divided by x test 7 dot max. Okay, we have to normalize it and then we can use it, right? In case if in any case without normalization you are not getting a better. Now after normalization you can see I am getting the probability of each neuron. Okay, and then if I do 9, almost same thing I'm getting. Okay, so without normalization we are getting only 1 or 0, but after normalization we are getting a probability of each particular value, each particular neuron. There are 10 neurons, so we are getting the probable value of each 10 neuron, right? So it is our prediction. I want to see the image, so how can I see the image? I can see the image simple like this. Import matplotlib dot pyplot as plt. Okay, plt dot imshow, that is image show. You can use any image like x test 7. Okay, image can be plotted on a two-dimensional axis. Okay, image can't be plotted on a single dimensional axis, so it needs to be again reshaped. It is 784 to 28 cross 28 and then plt dot show. Okay, it is what? 9, right? You can just change the location and you'll get different. If you are using normalized value, then also you'll get the same thing. You can see after normalization only the values gets the, you can say the values, they scale down, only values get scaled down after normalization. The meaning, or you can say the information is not lost, information is still there with the same intensity. Okay, change the location to something like 57 or 597. So we are getting 0. Let's see the prediction. Actual value is what? 0. Okay, and prediction is what? Is also 0. Better. And this is what we can do. Fine. So at the 0 we are having a maximum value. So it is a complete thing, right? So we understood how can we create a neural network model. We understood how can we test, how can we verify the accuracy and all, and we had seen how can we plot the things. Okay, so this is our first project done. Okay, now question over here: if I am having my own data, okay, or if I want to predict, suppose I am writing something over here. Suppose I have written, just imagine, just a minute. Okay, suppose I have written something over here, like I have written over here 9. Okay, then how can my model predict it is a 9 or what? Okay, I want that my model, because my model is trained, it is trained to predict or identify the handwritten digits, right? So it should identify these things also. I have written 2 over here, it should identify these things also, isn't it? So how can we do it? So let's see how can we do it. Okay, so that means using our own image for the prediction. Okay, as of now we are using only the given image, like the training image was there, that then the testing image was there. I uses training image, I uses testing image for the, for training image, for training, for testing image, for the predictions. Okay, and accuracy identification and all. I want to use my own image. Okay, so to use my own image I have to save this image first, isn't it? So let me save this image. I will take a screenshot of it. Okay, I will save it, and I will save this thing also. Sorry. Okay, two image I took. Okay, and thereafter what I will do, I will upload these images. These are the images that are present over here. 2 and 9. Okay, so I'll delete these images first. Okay, I'll rename it TW2, rename it NINE9, right? Two images are there, 2 and 9, right? So what I will do, I will upload these images over here. This is the icon to upload. Okay, the just to check my model performance on the image that I am passing, right? Thereafter, what I will do, I will read this image. Okay, so how can I read the image? To read the image, we use OpenCV. Okay, that is very simple to use. All right, so what I will do, read your images. Okay, this OpenCV that you may learn in upcoming classes, that will be used for any kind of image and videos kind of things. Okay, but here I will give you a very small, or you can say very brief of this. So OpenCV can be imported by CV2, and thereafter you can use what you can do, CV2 dot imread. Okay, imread what, any image, suppose image 1, that is I1 is equal to CV2 dot imread 9 dot png. It can be used for JPG, PNG, any kind of image, right? I2 2.png. Better. So you're having these two things, I1 and I2. If you check I1 dot shape, this is 132 cross 99 cross 3. Okay, that means why 132? Because 132 is your, number of columns, right? 99, that means 132 cross 99 pixels, and 3 is what, RGB, red, green and blue. Okay, there are 3 layers of image, that's why RGB, right? And I2 is what, this one. So can we make the predictions over these images? No. First of all, we can't make the predictions over these images because these images are in 3 dimension. The first reason. Second reason, we trained our images on a size of 28 cross 28, that is 784 pixels. Okay, my model can only use 784 pixels. It can't use 146 cross 154 pixels. My model is not comfortable with this size. Okay, because my model can only identify a image with a pixel size of 784. Okay, that means whenever you are going to make a predictions, the features that you are going to use, you have to prepare the features in a way so that your model can easily identify, your model can be comfortable with that, right? So that means, look here, first before moving ahead, what I will do, I will just use plt dot I am so I1. Okay, so you can see my image is recognized better, plt dot so. Okay, done. If I will give I2, it is getting recognized. Okay, so it's working, right? Now what I will do, I will just make a small change. I want to read the image in grayscale, so I'll just write 0 over here. That's it. It's been made in grayscale image, just 2 dimensional image, so convert it into grayscale. Now read it. So now it is like converted into. Next, what you have to do, we have to resize it in the way that your model can be, you can identify it. So how to resize? It's very simple. CV2 dot resize, it is not reshape, it is resizing. Okay, first it needs source is what, I1. Okay, and we have to resize it into 28 cross 28, correct? So it is what, I1. Okay, and resize I2 also, CV2 dot resize I2 cross 28 cross 28. Okay, and this will be what, I2. So it is resized now. So what, how it will change, let's see. So it's changed. Okay, size changed. Now it is getting comfortable for our prediction. Prediction means what? For our kind of according to our data that is used for training, but still it is not according to that. Okay, I1 is this one and I2 is this one. Okay, but still it is not according to the data that is used for training. Why? If you see, the dark color is in background and light color is used for, light color is used for drawing. Okay, dark color is in the background and the digit is represented by light color. Okay, but here the dark color is used to write the digit and light color is in the background. That means it is a reverse. Okay, light color is there on the background, okay, and dark color for the digit. That means it's a reverse, right? That means what, we have to reverse it as well. Okay, and to reverse, what we can do, we can use like maximum value of I2. If you check, if you call I1, you will see all the points where it is 0, here it is 255. Okay, that means it is a reverse. That means if anyhow we can convert this 255 into 0, that means it will be according to our data, right? So data that is used for training. So I1 is equal to I1 minus 255, correct? And I2 is equal to, okay, now just check, much better. Okay, so now whatever data that that I passed can be used for prediction for a model. That means whenever you create any model and you are going to deploy that model, and that model is getting ready to receive the actual data from this real world scenario. Okay, so in that case we have to prepare our system in such a way that my system will receive the data, pre-process the data, and thereafter that data will be given to our model for the predictions. Okay, so let's see the prediction. I will make the prediction for I1 first. Okay, so how to make predictions? Very simple. Model dot predict. Okay, model dot predict what? I1 dot reshape 1 cross 784, because 784 is used for training. This is the shape that is used for training, right? It will give us the prediction in terms of, okay, it is giving a prediction like this. Okay, it is giving a prediction like this, so it is not giving a prediction correct. Okay, why? Because I am not using a normalized data. So let's see by using normalized data, because it should give a 9. So what I will do, I will divide it. Okay, I1 can be divided by I1 dot maximum value, and then I will reshape. I'm using normalized data now. Let's see. Okay, it is what I'm getting. I will get the maximum value. Where is maximum? By using np.arg max, right? And let's see what I'm getting. So the prediction over it is 7. That means in this case the prediction is wrong. Okay, let me check the prediction for the second case. Only I2, I2. Okay, in this case the prediction is correct. Okay, for the case 2 we are getting a correct prediction, but for the case 1 I am getting the wrong prediction. Okay, there can be n number of reasons for that, right? So what we will do, we'll try again for this one. Okay, for 9 again I will try, again I will draw one 9, and let's see, then after we can understand what can be the reason, right? So let me draw a 9 over here. Sorry. Okay, let me take the image of it. Uh-oh. Okay, it took the image, right? Now what I will do, I will go to what happened. Just wait. Okay, so this is the image. I will remove this image for now. 9 is very close to rename it. 9 is very close to 7. It is identifying as a 7 because of some reason. So let's see with a new set of image, remove this image. So in some case, obviously, there will be an error. Load it now. Okay, and again do the process. I will execute this thing again because the file name is same. Okay, let's see how is it working. This is for I2, right? And this is for I1. So this time it is getting predicted as kind of a 3. Okay. So again, there are certain values that are missing over here because of the size of the image. Okay. The size that we use for the training is very small. Okay. And the size that we are passing over here is having a higher pixel value. Okay. So that's why it is not giving us that much accuracy in case of the real world things. Okay. That's why if we want a model that can work on a real world scenario, we have to use a higher, we're using a 784 pixels. We have to use a higher density, or you can say high resolutions images. Okay, if we use high resolution images, then only, or high resolution data, then only the model that we create can be a more generic model. Okay, can suits all the situation, can work better in any kind of situation, right? So it is what about the sequential model, right? So let's now move to the part, how can we use our own data set to make a predictions, right? So to do it, I will use some data set. I will use a data set from just a minute, let me put it into charge. It is getting discharge actually. Give me 1 minute. Okay. Okay, so let's see. So how can we use our own data? So for using our own data, what I will do, I will take you to the Kaggle. Okay, because Kaggle is a source of huge amount of data that we can work upon. Okay, google.com and Kaggle. Sorry, I will not download the data because again downloading and uploading will take time, so I can directly use Kaggle. So this is a Kaggle, right? Here you can get n number of data. Okay, you can create an account, you can get a n number of data, and you can work upon the data and you can do your research, right? And lot of data already there on which people had already worked. Okay, so you'll get a lot of help from this. This is an open source platform over where you can get a lot of help, okay, to work upon, right? So I will use a data. I will, let me click on data set. Mm, okay. Um, just a minute. Okay, so this data I can use, right? This is X-ray data actually. This is also a corona hack chest X-ray data. Okay, so this also we can use. This also we can use. So let me try with this one. Okay, this is your 2 GB of data, this is just 1 GB of data, this is 241 MB of data. So anyone you can use. Let me try with this. Okay, so over here we are having a data set that is given into three directory. This is your test directory. In this test directory we are having two folders. The one folder is representing the person's x-ray, which are having a all those person which are having a normal images, or in a normal they are not suffering from any pneumonia, right? So they are having the x-ray images over here. You can see in the train also it is a normal. I don't know why images are not coming over. I will show you the images anyway. Okay, these are the images of normal persons. Okay, and in this folder we are having a images of pneumonia person. Okay, don't know why images it is not showing. There can be some problem with the server or all. Okay, so what we can do, we can continue with this. We can create a model to identify this thing. Here directly images are there. Okay, so what we have to do, we have to click over new notebook. You can also go to this data set. It's a very good data actually. Let me share the data with you. So what we can do, we can click over new notebook. Again, directly we can use the data over here without downloading or doing anything. You can select the notebook type, and then you can select the GPU if you want. It is having a GPU support as well. Okay, GPU accelerator, and then create it. Okay, there is a code over here. I will just remove this code and I will start from scratch. Okay, so you are having a data over here, right? This is your data. Okay, train and test. In the train, in the test, we are having two folders, train and test. Okay, test is a folder that is also having some data just to validate your model. Okay, like how your model is performing, and train is a folder that is used for training your model, right? So first of all we have to read the data value. We have to read the data value before training. We need to read it, right? So how can we read it? Obviously we have to use something that is known as a library named OS. Okay, what is OS? OS is a library in Python that is used to access the directory of your system. Okay, that means over here you have to access the directory, isn't it? There are so many directories over here. Okay, there is a directory that is containing, just 1 minute, just a minute. Okay, so there is a directory that is containing the data of pneumonia person, and there is a directory that is containing the the X-ray image of non-pneumonia or the normal person. Okay, there are two directories over here. You can see directory one and this one. We have to access the directory. So how can we access it? We can access it like this: os.listdir. Okay, os.listdir. Okay, and you have to give the location. Okay, so let me give the location of this. Copy file path and paste it over here. Okay, so input checks SK pneumonia, and this is null. I will give it over train. No, just a minute. If I'll give it like this, what will I get? So within this folder there is a folder called chest x-ray. So I have to access this folder. So just again give chest underscore x-ray. So I'm getting this folder. There are 1, 2, 3, 4 folders: chest x-ray, Mac OS, VAL, test, and train. I have to work with train. Okay, I need a train kind of thing. So what I will do, I'll again give over here train. So in the train we are having two folders, normal and pneumonia, right? So I'll give over here normal. Okay, what I'm getting in the normal, I execute it. These are the different files. Okay, these are the different files. These are different images. Those images we have to read. Correct. So once we read the image, then only we can create a data frame. Correct. So how can we read the image? Already I told you we can read the image with the help of CV2, isn't it? That means these images we have to read one by one for creating a data set. So what I will do, I will just do one thing. I will just cut it out first of all. Control X. Okay, and what I will do, I will define location 1, which is for pneumonia person, location 2, which is for normal person, because I have to access data from two different locations, right? And then what I will do, in location 1 I will paste, okay, this complete location, okay, this complete location I will paste over here. And for the second one, this normal I will replace with pneumonia, PNUPNEUMONIA, correct? And this thing I will remove, not required now. Okay. So two locations, because I am having these two locations, all the data are present, isn't it? If I will write os.listdir loc1, then all the elements from that location will be there. Okay, all the images from that location, location 2, all the images from the second location, that is there, right? So it is what that we are getting. So what we will do, we will read these images one by one, and I told you to read the image we can use cv2. So cv2 if can be used for single image, cv2 can be used for multiple images as well. Okay, cv2 you can use for single image, cv2 in this case we can use for multiple images as well. That means what we will do, we can use for I in os.listdir, which is a list, print I. That means one by one we are accessing the image. Okay, one by one we are accessing the image, right? So what we can do, in case of print, I can also do over here cv2 dot imread. That means I am accessing the image one by one. That means one by one I will read the image in a loop, right? So if I read, it is showing error. Okay, what error? cv2 is not defined. That's better. Let's import cv2. Okay. So once I execute it, I am getting nothing over here. You can see, if it actually read the data, right, it should show the matrices. Okay, it should show the value, it should show the matrices of the data, but it is showing nothing, isn't it? It should show the matrices of the data, but it is showing what? It is showing nothing over here, isn't it? That means it is not reading the data actually. Why it is not reading the data? It is not reading the data because to read any data, okay, you have to pass the complete location. Okay, this is a complete location. Okay, you can't pass directly image. So what is a complete location? The complete location is this one. If it is location 2, then it is your complete location, that is location 2 plus I. Okay, can we pass it like this? No, we can't pass it like this. Okay, how can we pass? We can pass like this: os dot path dot join. That means we are joining the path. Joining the path of what? loc2 comma any file name. Okay, what can be the file name? For example, I'm just uh, taking it. Okay, just a minute. Just print I over here. Okay, print I. Just use any file. Suppose this is a file name, right? So I'll just copy this file name. Okay, and thereafter I will paste it over here. Okay, so what will be the output? Okay, so it is not defined, so it should be within quotes. You can see the complete file name is defined. Okay, so cv2 can only read the data if full file path is given. It is not like that any half file path or anything you can give over here, isn't it? So it can read the value if full file path can be given. That means we have to do what? We have to use over here cv2 dot imread. Okay, and within imread we have to pass this thing, path join. This particular thing will join the path. Okay, join the path of what? Join the path of loc2, which is containing the path comma I. That means each time you will get a new path. Just look here. Okay, each time whenever loop is executing, you are getting a new path. Okay, whenever loop is executing, after each execution we are getting a new path. That means what we can do, we can use this thing to read cv2.imread. Okay, it will read the value, and now you're getting it is reading the images. Okay, it is taking time to read image, isn't it? You can see now it is not getting executed very soon. Okay, there is a star mark over here. A star mark means what? It is reading the image. There are so many images, so it will take a little time, 5 minutes or 4 minutes of time to read the complete image, right? So let it be done. I will tell you how you can make it faster also. Okay, because we have executed it, so it is taking a little time. Okay, let me do one thing. Cancel the run. Okay, and let me read it in grayscale format. Correct. As well as uh, okay, f1, that is feature 1. Okay, feature 1 is equal to this one, and then what we can do, uh, feature features is equal to null array. Okay, and I will do what, features dot append f1. Okay, as well as I want to monitor it, so I can use from tqdm import tqdm. Okay, and I can put over here tqdm. Okay, so you can see it is reading the images. Okay, so with the tqdm we can monitor it, like what is the process going on and how much is remaining, right? So it is total 3875 images. Okay, so it is reading them. Okay, and reading them and basically extracting the feature of those images. Okay, for our neural network processes, right? Because we have to create a neural network, so features are very important, right? And we were having a raw images, so we are extracting the feature of, because we are having jpg images. Okay, I will show you the image also. Let it be added on. Better. So these are the features. These are the features that we are getting. Okay. So it is a feature of all the images, right? It is a feature of all the images of a pneumonia class that we got, right? What is the shape of it? Dot shape. There is no shape showing because shape is a attribute of numpy array, not of list. So just import numpy as np, and then okay, 3875. Okay, it is having a shape of 3875. Why the other dimensions are not showing? It is showing only the first dimension, that is number of samples, isn't it? It is not showing the other dimension. Why is it not showing other dimensions? It is not showing other dimension because all the images are of different sizes. Okay, like some images are of size like 30 cross 30, some images like 50 cross 70, some images like 100 cross 200, some images like 30 cross 70. Okay, as all the images are of different sizes, it is not uniform. The other dimension it is not showing. Okay, and you should take care whenever you train a model. Okay, whenever you are going to train a model, you have to train a model on a data which is uniform in shape. Okay, you have to train a model on a data which is uniform in shape. Okay, it is not like that we use a data like first sample that is containing 100 features, second sample only 20 feature, third sample again 80 features, fourth sample again 70 feature. Okay, it is not possible. Okay, if we are using a data, then all the samples should have uniform features. First sample 100, second 100, fourth 100, everyone should be 100, right? So what we have to do, we have to resize it now. So f1 is equal to cv2 dot resize. Okay, resize what, f1 cross or f1r I will use for resizing. F1r is equal to cv to f1r f1, um, what size I can use? Suppose I'm using a size of 70 cross 70. Any size I can use, but I'm selecting 70 cross 70, right? So it resized now. So again, features are getting extracted. Then and then check the save. Oh, sorry, I have to append F1R over here. I am doing a mistake. Done. Okay, then check the save. So this is it. Better. Now what I can do, I can take any single sample just for verification, features, 78, any single sample, right? And then we can use it for image generation, right? So import matplotlib dot pyplot h plt, okay, and then plt dot imshow, okay, okay, and then plt dot show, okay. So we are reading the image over here, okay. That means my feature extraction is completed, okay. So once my feature extraction is completed, obviously I can use that feature for training my model, right? So it is our feature extraction that is done, but this is a feature extraction only for one set of data. That is what? That is your pneumonia set of data. There is no normal person. So what I can do, I can again use the same loop just below it. Okay, os dot here location one will be used. cv2 dot im, it can be your f2. It can be your f2r. Okay, it is what location one. Okay, location one, that is containing normal. Os.list their location, cv.im read, path is joined, location one, cv2.resize f2, okay, and feature.fn f2r. Correct. That means now I am doing it for the second one also to increase my feature size. Right. So let's execute it. So now, as of now, the first loop is going on. Then after second loop will continue, and we will have a ultimate data set that will contain, this is a image of pneumonia person, right? Second, 1341. Okay, so you can see we are having a feature extraction completed. Okay, 5216 samples I am using. Okay, if I will use anything like 4000, okay, I will get, this is what I am getting. Okay, this is a image of normal person. Okay, and this is a image of pneumonia person. Okay, done. So it is what we got over here. Next, what we can do, it is not just feature is required, we are required with the labels also. So it is a process of, you can see how easy it is. Okay, if we are having a data in your system, like in D drive, E drive, F drive, or anywhere like in the Google Drive, so you have to just give the location, and after giving the location, you have to just change the location over here, and your feature will be extracted. Okay, once the features are extracted, okay, you can do a lot of things. For example, you have to use this feature again. Okay, so what you can do, just see over here, you are having features. Okay, this is your complete feature. Okay, it is a feature of shape 5216. So what I will do, I will reshape it. Okay, and I will give it 5216 749 4900. Okay, so it will be reshaped. So you may be thinking, okay, reshaped. Okay, np.array. You might be thinking why I am reshaping it. I will let you know why I am reshaping it, right? So it is reshaped now, and thereafter what I can do, I can use it, for example, to convert it into data frame by using pandas. Import pandas as pd. Okay, and I can convert it into data frame like this: pd dot data frame. Okay. You can see this has been converted into data frame. Okay, total 4899 columns. Each column is representing the features. That means if you want to use the data, you are not required to download the complete image data. Okay, if you want to use this data, you are not required to download the complete image data. Rather, what we can do, we can convert the data into features, and then we can convert the features into pandas data frame, and we can store this thing over here. Like what I should do, X-ray data. Okay, and this can be converted into the file also. Okay, how it can be converted into a file? It can be converted like this: pd dot to underscore csv. Okay, and we can pass over here X-ray data, right? X-ray underscore data. Let's see. Okay, pandas has no attribute to csv. There is something that, let me check. I am just missing the function name, I guess. Pandas function to write csv. Okay, it is saying to csv only. I guess it is not receiving the things. Okay, df dot to csv I have to pass. Okay, fine, I got it. I have to pass X-ray data dot to csv, not pd dot to csv. Okay, X-ray data dot to csv and X-ray data, and then it is saying what I can pass index equal to false and all, that is not required. Okay, this is just this will just ignore the index. So what it will do exactly? It will create a CSV data of the features. You can see in the output it must be there. Where it's gone. It is very, it is stored somewhere. I can't see it. Why I can't see it? It takes a little time. It will be shown in the output section only. It is taking a little time. It gets stuck somewhere. So you can wait for time. Okay. In the output section, we'll get a CSV file that we can download for our further uses. That means for our kind of a system use or for any other use, right? So just a minute. Get stuck. don't stuck usually, but it is stuck over here. So after some time I'll show you. Okay, let us continue. Okay, after some time I'll show you. There will be a CSV file created over here. Okay, there will be a CSV file created over here that can be used for any other things that we want to use. Okay, that I will show you. Let it be refreshed. It is stuck actually. Okay, I will show you, right. So you will definitely get a CSV file, right. It depends, like Kaggle is it might be some problem with the server because it is getting an issue over here. Okay, anyway, we'll use it later. So one part of our job is done. That means feature has been extracted and feature is stored in where? Feature is stored in features. Okay, features are stored in features. Okay, so let's continue for the next part. What is not working? Stuck. It's a huge data. That's why it is taking time to convert it. I can't do anything. Okay, okay. So let me tell you what next we have to do. We have to just make a function. We have to just make a process to extract label, and thereafter we'll create our model. Okay. So this time I will create a functional model. So before creating a functional model, let me explain the functional model. Thereafter I'll create it. Right. Just a minute. Let me explain the functional model in Keras. What is functional API? Till then it will be done. Okay. So if you talk about sequential model, so sequential model works like this. You are having this neurons, input neurons, then you are having a hidden neurons, then you are having a output neurons. Okay, so these, and there can be multiple hidden neurons, isn't it? There can be multiple hidden neurons like this. Okay, multiple hidden layers. Okay, like hidden layer 1, hidden layer 2, hidden layer 3. Okay, there can be multiple hidden layers, right? Multiple hidden layers, right? So this first input layer is connected to first hidden layer, this is connected to next hidden layer, this is connected to next hidden layer, and then the output layer. Okay, so it is how the sequential model works. But in functional model, what we can do, we can make a skip. That means if you want to skip any hidden layer, we can directly jump over here. Okay, I can skip this part. Okay, that means suppose initially I created with 3 hidden layers. Okay, initially I started the process and I created 3 hidden layers. Okay, then I have to check my model, like how it is performing without this middle one. Okay, I have to check like how it is performing without this particular middle one. Okay, so in sequential model I have to manually remove it. Okay, in sequential model I have to manually remove this particular hidden layer. Okay, but in functional model, what we can do, we can just with a small change we can just skip this particular hidden layer. Okay, that's how your functional API or functional model works in Kaggle. Correct. So for this model preparation, I will use functional model only, so that we can come to know that okay, we are having two options to create the model. Okay, sequential and functional, and how both of them can be used. Right. So let's check it. I hope it is done. It is stuck actually. Just a minute. Why it is stuck? Why it is not performing anything? Just give me 1 minute of time. It will get settled down. Sometimes it happens, it gets stuck, but we can solve it out. I don't want to write code again. but it is creating a problem. Okay, close it. Now it's better. Sometimes some steps generally creates a problem. For example, because of this steps it gets stuck. Okay, so better you should use this step at the end of your code, right? It. Okay, then again I will execute it. Done. So right, so we get it better. It's working quite good. Right, now what we can do, we have to extract the labels, right? We have to define the label. So because we have defined the features, we have to define now labels. So how can you define the labels? We'll define the labels with the same logic, okay, with a little change. So I'll just copy this whole part and we'll paste it over here. Okay, and here I will make a small change. Labels is equal to nothing for I in this one, and I will remove these parts. Okay, so what I will do for location 2 is representing what? Location 2 is representing, in my case it is representing the pneumonia guys, right? So for the pneumonia guys I will use a label called 1, right? So what I will use, labels dot append 1, just 1, that's it, right? For location 1, okay, I will use labels dot append 0. Okay, so it will append the value 0 for labels. Okay, and I will execute it and just check things are done. So two things have been appended over here, labels, if you see. Okay, 0 and 1. So that means what? We got the our things. X is equal to features. Okay, Y is equal to what? Labels. We got it. Okay, so after we got X and Y, what we do, we generally divide the things into training and testing. Okay, so since I'm not using the other file, that is a test file, because again if I use test file, again I have to extract the data and do a lot of things. So I will use, what I will do, I will separate this thing only into training and testing. So from sklearn, you may have used this thing, sklearn.model selection. Okay, it is what? Dividing the training data, dividing the data into two parts, training data and testing data, right? Import xtrain, sorry, import train test split. Okay, it will divide the data into two part, xtrain, xtest, ytrain, Y will be divided in two parts, Y train and Y test. Okay, is equal to what? Train test split. Okay, and X comma Y. And before doing it, do one more thing over here. Features converted into np dot array. Okay, and this also can be converted into np dot array. Much better. Okay, so X and Y has been generated. Okay, and X and Y can be splitted, right? So you can split it. Once it is splitted, thereafter we can go forward for model preparation. Okay, now we are having a data in training and testing. 75% of the data is in training and 25% of the data in what is in testing. Okay, so now we can go for the further use. Okay, for the further kind of a process. Okay, so what further process required? The further process required, the very first thing, that is known as your normalization. Okay, or before normalization and all, let me import the required libraries. So import Keras. From Keras import model. Okay, that as usual from Keras dot layers import. Here we import dense layer and all. So dense layer or dropout layer. So I'll use a star. A star means everything. Okay, I'm importing everything. That's why I'm using a star over here. Right. From all the kinds of layer will be imported from Keras import optimizes. Okay, and rest what we need that one more thing that is known as categorical. Okay, so for categorical also I told you what to use, utils, right? So from Keras dot utils import to categorical, right? So these are my libraries that we used earlier. Again we are using this library, but this time we are using it for functional model, not for sequential model. Okay, thereafter what we have to do, we have to do normalization, because you can see, like last time without normalization, what was the effect? Without normalization it was just around 9 to 10%. With normalization it was 95%. Okay, so we have to use normalization. Okay, and we have to use one hot encoding, isn't it? One hot encoding. So normalization will be done where? Normalization will be done on X train. Okay, X train, X test, Y train, and Y test. Sorry, X train and X test. Okay, so X train underscore n is equal to X train divided by whom? X train dot maximum normalized. Okay, the same way X test underscore n is equal to what? X test divided by X test dot maximum. Okay, so this is normalized value that will be used for training and testing. One hot encoding will be done over Y train and Y test. Okay, so Y train is equal to Y train one hot encoding. I will just represent with E. Y test, that is your encoded value, Y test E is equal to 2 categorical. Okay, what? Y test. Better, sorry, Y train. Okay, and same thing for Y test, 2 categorical. You can do it manually also, but why to do manually if already we are having the libraries, right? So you can see Y train E. So this is your Y train, which is representing 0 and 1. Okay, 0 for something, 1 for something. Okay, and Y train N. This is the one hot encoding. Sorry, Y train E. Okay, it is one hot encoded. Okay, if it is 1, the second index is having a higher bit. If it is 0, the first index is having a higher bit. Okay, so it depends what you want to put 1, what you want to put 0. Okay, so now our data is completely ready. We have imported the algorithms and all. The only thing that we have to do is now we have to define our model. Okay, and once we defined our model, we can make the use of it. Correct. So we had defined the data, we had one hot encoded, and all those things we have done. Okay, so how can we define the functional model? So functional API of Keras. Okay, so functional API of Keras, how we can define this thing? So for defining the functional model, in the functional model, each particular layer will be defined with a variable. Okay, it is not just model dot add. Okay, it is not just model dot add. That means what? We start with input layer. So input layer, then can be hidden layer 1. Okay, then can be hidden layer 2. This is how we define. Okay, it is not just model dot add. Then can be hidden layer 3. Okay, and there can be output layer. Okay, so input layer will be defined. How we can define input layer? Input layer will be defined with a input. From where this input is coming? This input came when we have imported this thing. Okay, from keras.layers import asterisk mark, that means all kind of layers had been imported. So one of them type is input. Okay, you have to define the shape of it. Shape, what should be the shape? Shape will be according to the shape of your data. So shape of your data is what? Xtrain.shape. Have you checked? No, we have not checked, right? So just check the xtrain.shape. Xtrain and sorry, xtrain and dot shape. It is 70 cross 70, right? That is 4900. Okay, that means 4900 pixels it will have. Okay, and we should also reshape it better, because this 3 dimension can't be used. So just reshape 3912 into 4900. Better. And what is the shape of X test? Just a minute, let me check the shape of X test. Okay, 1304, right? So it is 1304 cross 4900. Okay. So this is your X train underscore n equals X test underscore n equals. Okay, now what happened? Okay, dot reshape, sorry. Done. Okay, so that means input is defined with a variable called input. Now second, hidden layer. How hidden layer will be defined? Hidden layer will be defined with a dense layer. From where dense is dense came? When we have written from keras dot layers import asterisk mark, that means all the layer had been imported, right? Dense layer. So in the dense layer, how many hidden layer I have to define? Suppose I want to define 200 hidden layers. Sorry, 200 hidden neurons. Okay, so this time I'm not using 16 multiple, right? I'm using normal one, so that you should not think like only 16 multiple can be used. Okay, ReLU. Okay, this is what I have defined. Okay, and thereafter if you want to define, that is optional. Okay, if you want to define the name of this particular thing, that also you can define like h1. Okay, this is your hidden layer first. Okay, then we can define a hidden layer second, then we can define a hidden layer third. Okay, and then we can define the output layer. Okay, in output layer there can be two neurons, because there are two kinds of person, normal persons and the that one person, and here it can be what? Softmax. That's it. Okay, and I will define this thing as a h2. This is not mandatory, this is just optional, just to recognize. And this is your o1 output o. That's it. Okay, now these will not be connected with each other. Okay, we have to connect them. Okay, to connect them I have to call the name of the layers which is present before it over here. Okay, that means if I have to connect the hidden layer with input layer, I have to call input layer over here. I have to connect hidden layer 2 with hidden layer 1, so I have to call h1 over here. I have to connect h3 with h2, then I have to call h2 over here. Okay, and over here h3. Okay, so this is how all the layers are now connected to each other. Okay, so if they are connected, then our model will be defined. Okay, so how can you define the model? At the end, you have to call model. Okay, you can see in the sequential thing we used to call model dot sequential at the first, but in functional we call model at the end. Okay, model, this is your input and this is your output. Okay, and this is going to be your final model. Okay, and then you can check the summary of it, model dot summary. Okay, so you can see total trainable parameter is 10,61,002. Okay, the first 4900 cross 200 plus 200. Okay, second 200 cross 200 plus 200. Okay, third 200 cross 200 plus 200, fourth 200 cross 2 plus 2. Okay, these are the trainable parameters. Better. And what I told you, this is your hidden layer 1 h1, h2 and h3. These are the names that we have defined. Okay, then what I told you earlier, if you want to skip any hidden layer, what you can do? Okay, if you want to skip any hidden layer, what you can do, you can just make a skip like this. I don't want to use, for example, h2. Okay, then I can directly put over here h1. Okay, then h3 is directly connected to h2, sorry, h1. Okay, and then if I execute it, you can see number of trainable parameter decrease, and from h1 you directly jump to h3. There is no h2. Okay, so this is how your functional API works in when you are using Keras. So it depends upon you what do you want to use. You want to use functional, you can carry on with the functional. You want to use sequential, you can carry on with the sequential. Okay, okay, now we have to train our model. How can we train our model? We can train our model with the help of some, now I will add one more parameter over here, that is called learning rate. Okay, learning rate defines the speed of learning. So like you asked me, like what is fine tuning? So this is called fine tuning or hyperparameter tuning. Okay, that means we are now tuning the hyperparameter called learning rate. So if I make it a small 0.01, that means my learning is very slow. Okay, so suppose with the slow learning things are getting done, with the fast learning things are not getting done. So we usually change this learning rate. Okay, and we try to figure out at what learning rate we get a better situation or we get a better model. Okay, then we can define epochs. Epoch, suppose I'm defining 30, right? And we can define batch size. Batch size anyway we can define later on also, that is not so important. Then we can define what the optimizer. So SGD is equal to optimizer, optimizers dot SGD, correct? Optimizers.sgd. Okay, and you can see earlier we had directly called optimizer in the compile section. When we compiled our model, at the time of the compilation we directly called the optimizer, but here we are not calling there only. Okay, here we are defining it earlier. Why we are defining? Because we have to define learning rate over here. LR is equal to what? This learning rate. So we'll try with different learning rate. Let me start with this one. Okay, so it is defined. So these are the entity that will be used while we compile the model. So just compile the model, model.compile. Okay, model.compile, and what we can do, we can use loss is equal to, as earlier, categorical cross entropy. Okay, optimizer is already defined, right? Optimizer is equal to SGD. It is defined earlier, that's why I am using as a variable over here. Matrix is equal to accuracy, because we are going to monitor accuracy. Better. And then we can fit model dot fit x train comma y train. Okay, batch size I want to define, so I can define batch size also. Batch size is equal to anything like 100. Okay, epochs 30 has been defined. So let me define epochs directly over here. It is not required to define over here. You can just remove it. Epochs is equal to 30. Okay, there is no fixed size like what epochs we have to define. It can be defined anything. And thereafter validation. Last time validation data was not working. Let me check like it is working. It should work like right. There must be something I missed. X test comma y test. Okay, that it will really validate here only. That means later on dot evaluate will not be required. Okay, it is not required to evaluate further. It will validate everything during the course of training only, right? So let me execute it. So it started the process. Again it's stuck in validation. Why? I received it, right? Sorry, x train underscore n, y train underscore e, x train underscore n, y test underscore e. I received it, right? Why it is not working? I received it 4900. It's better x test and x train. And this is also done. Y test underscore e. Getting me getting a challenge for validation only. I guess there must be certain update that I have not seen. Because of that, I am getting this particular problem. So this is how we used to put the validation data. Okay, let me remove it. I guess there must be some update in the backend. That's why it is not working. Okay, so let me execute it like this. Again, it is showing error. EPOCHS, epochs. Is it not correct? Oh my god. This is what I used last time, right? Just a minute, let me check again. Epochs will be passed like without epoch, how can it train? Give me 1 minute. It is missing something. Mhm. Give me 1 minute. I will again refresh it. Learning rate is defined. Loss is compiled. Matrix accuracy. Epochs is 20. Okay. So now it is working. So you can see it started with accuracy of 77%, then 81%, then 84%, then 87, 88, 91, 92, 93, 94. Last was 94. Okay. So after 20 epoch, we can increase the epoch as well. I will show you. I will try to increase the epoch. Okay. At the end, I will evaluate on the test data. So model dot evaluate x test underscore n comma, that is a normalized value y test underscore e. Okay, so here accuracy is 77%. Okay, so that means the accuracy over training data is very high. Accuracy over the unknown value is not getting that good. Okay, so we can say that it's a overfit kind of a situation that we are getting. Okay, we can say that my model is getting little overfit, right? So what we can do, we had not applied any dropout over here. Okay, we had not applied any dropout over here. That is also a thing that we had not applied any dropout. That may be the reason, right? So let me do one thing. Just go over here and let me change this learning rate a bit, right? Let me make it 0.01. Okay, and let me try with only one hidden layer. As of now, two hidden layers are used, right? So H3 directly try with H1. Okay, hidden layers will decrease, the number of weights will obviously decrease. Okay, so hidden layers decrease, number of weights decreased. Learning it also, I make it little small. Okay, again I will compile it and again I will fit it. So 91% is still, it touches 92%. That's better, but over here also the accuracy should be good. So now it is, you can see it is not overfitted. Okay, now accuracy on the testing. So this thing needs to be considered. Okay, so it is called fine tuning of your model. That means when we create a model, we just verify that the training accuracy should not be very high as compared to testing accuracy. Okay, for example, I train it for 20 epochs. Okay, if I will train it for more 20 epochs, let's see what will happen. I train it more 20 epochs. Okay, so my accuracy touches 93%, almost same. Okay, and my testing accuracy is what? Testing accuracy is also 93%. That means my model is getting better. Okay, so fine tuning depends upon, or you can say model tuning depends upon so many things. Okay, while we start building a model, we just build a model. First we check the training accuracy. It is not just training accuracy that affects a model, right? It is testing accuracy also needs to be checked. Like you can see, like first when I created this model, the training accuracy was 94%, but testing accuracy was what? Only 77%. Okay, that means my model can't be used for any kind of deployment purpose. It can't, it is not a successful model. We can't say that, okay, my training accuracy is 94%, please consider my model. It can't be considered until unless on the unknown data value model will give a good set of accuracy. A model can't be considered, right? So I trained it for 20 epochs, sorry, 40 epochs, 21st, then again 20. Let me execute it for 20 more. Okay, now it is touching 94%. Okay, it will continuously improve after 60 epoch 94. Then what is the testing? 94. That means both are improving. If both are improving, that means we can continue with both of them. Okay, we can keep increasing the epoch and keep going in that direction where things are improving. Okay, where things are now, it is getting at a constant 94.71. Okay, 94.86. Okay, that means on unknown and known, on both the case I am getting a 94% accuracy. And how I achieved it? I achieved it in two way. First, what I did, I decreased the number of hidden layers. Okay, now only one hidden layer, input layer, one hidden layer, and then output layer is used. Okay, that's how the number of learning parameters decreases. Second, I make the learning rate little small. Okay, so what is the effect of learning rate? Let's see by creating the model again. Okay, do one thing. Okay, start it from here. One hot encoding. Okay, and let me keep the dense layer same as it is. Okay, and this is your model dot summary. Better, and let me make a learning rate 0.1. Okay, and just see the effect. We can see the effect like what learning rate tuning do. Okay, then again apply it. So I increase the speed of learning. Okay, and effect you can see. Okay, as I increase the speed of learning after 20 epoch, it is just 74% accurate. Okay, and testing is also 74% accurate after 20 epoch. So you may think if I will increase the epoch, then accuracy will increase. So let's increase the number of epoch. Execute it for 20 more times. But still, it is now 93% accurate. Okay, and for testing, 84% accurate. Right. That means now again it gets overfitted. Okay, now again it is like forcefully training your model. Again it is a situation where your model is trying to memorize the things. Okay, instead of getting trained, like there are two types of student. One who understood the concept. Okay, and then after understanding the concept, they used to write the examination paper. So that particular guy who is understanding the concept and then he is writing an examination paper, he may get a little less marks. Okay, as compared to those students who memorizes everything, who just remembers everything, and then they are writing the exam. So they, like, after memorizing or after remembering each and every line of the book, okay, someone may get a very good marks, but the person who gets less mark with the concept understanding, his capability is more as compared to that particular guy who gets a good marks but he just learn everything. Okay, his capability is less, right? Same thing happens over here. If a model memorizes everything and after memorizing it is giving you a very high accuracy, so that model will not be considered as a good model. Okay, that model will be considered a good model. Even accuracy is less, but the training and testing accuracy both are very close to each other. So overfitting needs to be very much. For example, if I will, you know, execute it for 20 more times, total 60 times, right? So after 60 times, my accuracy is 94 or 95. Okay, but testing accuracy is what? Testing accuracy also touches over it. That means now it gets better. Okay, with the increasing of things, it gets better. So we have to achieve that particular situation, right? And we have to check it for another sets of data as well. Okay, like it is having some other sets of data also present. You can see that test data. So that also you can use for testing, right? And if I decrease the learning rate to 0.01, you can see things will get much better. Again, define your model. 0.01. First I use 0. Okay. So it is much better situation than both of them, because only after 20 epoch we get a better thing, 94% accuracy. And this is what we are getting, 92%. So it is the best thing that we are getting. Okay, that means we tried with a learning rate 0.1, we tried with learning rate 0.01, we tried with learning rate 0.001. Okay, but the learning rate 0.01 is giving us the best possible situation, because in just 20 epoch, okay, just in 20 epoch it is giving me 94% accuracy, and for testing data also it suits. Okay, for testing data also I'm getting 94% accuracy, sorry, 92% accuracy, right? So this is how you can create the things, correct? Apart from this, a lot of other things also can be used over here. Okay, like when you tune the things, you can't rely upon only one factor, right? You can use something that is known as dropout as well. Okay, dropout also can be used. For example, let me tell you, I will do what, I will just copy this thing. Okay, and I will paste it over here. Okay, and now I will use everything, like h1 is used over here, h2 will be used over here. Okay, and h3 will be used over here. Okay, I will use everything over here, right? All the layers I'm using, I'm not skipping anything, but I'm adding dropout. Okay, so many times we can continue with dropout as well. There are so many techniques, okay, to avoid overfit. Okay, to avoid overfit, there are so many techniques. One I had shown you: decrease the number of hidden layers. Okay, decrease, use that much hidden layer only that is actually required. It should not be very less and it should not be very high. In some case you may require two hidden layers, in some case you may require three hidden layers. Okay, so you have to figure it out. Okay, it is just a hit and try. Okay, that means for different cases situations will be different, right? So I can't give you a predefined rule, I can't give you any kind of a law for that. Okay, that will depends upon the situation to situation, isn't it? So in that case, it depends. You have to figure out. So you can manipulate the number of hidden layer. Second, you can use dropout. Third, you can use batch normalization. Fourth, you can use regularizations. Okay. So these four steps are primarily used. Obviously, batch normalization and regularization you may get in the further classes, but dropout I can tell you in this class only. Okay. So how can you use dropout? You can use dropout like this. This can be like D1. D1 is equal to dropout. What I will drop out? How many things you have to drop out? It can be like 30% or 40%, whatever. Suppose 40% like this one, and then you can use over here H1. Okay. The same way. Sorry. D2 H2. Correct. D3 H3. Okay. 40% here, 50%, and here I'm using 60%. Okay. And here I can use what? D1, and here I can use what? D2. Sorry. And here I can use what? D3. Much better. Okay, so it is done now, right? So once it is done, let us use the same thing, learning rate and all. Okay, so this time I'm using all the things, compile all the layers. Let's see if it is getting overfitted or not. Ninety-four, 93, 93, 94, 94. So because of high number of weights, this is how it is performing. Okay, and then 95. So you can see with the dropout this time I controlled overfitting. Okay, I increase the accuracy as well from 94%. It goes to 95%. So I increase the accuracy as well as I control the overfit by using dropout over here. Correct. What other things that we can use? Those things that you'll get to know other like in upcoming classes. Apart from that, people also uses different optimizers. Okay, also different optimizers are used over here. For example, there is a optimizer called Adam. Okay, so Adam optimizer is also used. Okay, and there is RMS prop optimizer is also there. Okay, root mean square. Okay, so those optimizers also you can try. How you can try it? Simple. You can just use Adam over here. Adam is equal to, just replace it. In some case, if SGD is not working for you, you can use it like this. Okay, that means okay, Adam is not supported. I guess I'm doing some mistake. Just a minute. Okay. optimizers dot Adam. I guess it is ADAM. Okay, then compile it. Okay, so with Adam optimizer also you can try. So with Adam optimizer, it is also working much better, touches around 96% of accuracy. Okay, and evaluation purpose 95, almost it is working in the same way. So basically you can try with different optimizer as well. There are basically three optimizers used mostly. One is Adam, one is also, there is also one optimizer. Let me use that part also in code, because first I use SGD, the stochastic gradient descent, then I used Adam. Let me use one more, that is known as your RMS prop. Okay, so just copy and paste. So it is almost all of the optimizer came out of gradient descent only. Just a little bit differences are there. RMS. Just a minute. I have to check it because I am just missing something over here. The spelling might be missing. So RMS optimizer. Here they are saying Adam. This is how you can use Adam. And where is it? RMS prop? This is SGD. This is your RMS prop. There are these many optimizers are there. Okay, so you can try with these different optimizers when you're using it. So this is how you can use it. RMS prop. I will copy it and I will paste it over here. Okay, so done. And then I will again try to check my model how it is performing. Compile this thing. So three models I have created. Okay, with three different situations. Okay, and all the three models are working good. Okay, with Adam and with hidden layers, with dropout, things are working much better as compared to the case where we are not using dropout. So with RMS prop, it now touches around 96% of accuracy. Okay, on training data, but it is not just about training data. We have to check over the testing data as well. So just use testing data. 96. Okay, so this is your best model that is created, the third model that is having a highest possible accuracy. Correct. The same name I am given each time, model, so it is getting overwritten. You can try with different names. Okay, now you have to make the predictions. So how can we make the predictions? For making the prediction, already I told you we need a value x test n, that is your the data, that is your normalized data. If the normalized data is not there, you can use the normal data, the actual data, and then you can normalize and then you can make the predictions, right? Just take any value called, like suppose 67th value. To take the image of it, plt dot imso, okay, dot reshape 70 cross 70, okay, and plt dot so, right? So it is our image. I don't know what is this. This is a pneumonia guy or this is a normal guy, right? So what I can do, I can use model dot predict. What I can predict? I can predict this thing. Okay, but prediction can be made only on two-dimensional data. But if I take a single sample, it will be a single dimension. So I will reshape it 1 cross 4900, right? And then I will make a prediction. So this is what a prediction I am getting. Obviously, I am getting a prediction in for both the neurons. This is a value of first neuron. This is a value of second neuron. So what I can do, I can use over here np dot argmax. Okay, and it is what I am getting. 0. 0 stands for what? 0 stands for, as for the kind of a things, the value. First of all, we will compare this thing. Just a minute. This is a prediction. Okay, and we will also use the actual. So how can we get actual? Actual is present in y test 67. Okay, actual value is in y test 67. So actual value is also 0 and predicted value is also 0, isn't it? That means obviously for maximum case it will the prediction will be correct, but 0 is representing what? 0 is representing that we have to check. Okay, let's see. Okay, 0 is there for location 1 and 1 is there for location 2, right? So location 1 is what? Location 1 is your normal, okay, and location 2 is pneumonia, right? So what I can do, I can just create a array over here. Okay, the array can represent mm, chest or predicted label. Predicted label is equal to what? Np dot array, okay, normal, okay, comma pneumonia, Neumonia, pneumonia, right? Okay, so this value can be passed over here. That means here we are getting 0 or 1. That means if this 0 or 1 can be passed through this array, that means I will just pick this array from here, okay, and I will put it over here, okay, and I will call this 0 or 1 within this array. But we have to give the just a minute. Yeah. So you can see the prediction is what? Normal. Okay. Now we are getting our project done completely. That means the final prediction is what? Normal for the case 67. Okay. If I will change the location, let me make it something like 35. And here also it can be 35. And here also it can be what? 35. It is a 1. Okay. Prediction is what? Pneumonia. Actual is 1. 1 means what? Pneumonia. And then the 1. Okay. That means whatever the X-ray image that will be given to this model, okay, so it is predicting with an accuracy of almost 96 to 97%. Okay, more accurate it can be, but any model we don't prefer to go to up to 100% because 100% model generally considered as a overfit model. So if 97 to 98% accuracy we achieved, that means that is a very better model that we can trust upon that. Okay, so I had given you two different things. Okay, you can see it is giving a prediction for two different cases, one for pneumonia, one for that one. Both are getting predicted correctly. Right. Okay, now I have to share this code with you. How can I share this code with you? I will save a version of it first. So just a minute. What is this? Which model I used? It is sequence functional. Okay, functional model ANN chest X-ray image. Okay, so I'll save the version of it first. Quick save. Okay, and there I will share it, make it public with a copy. This is a URL. Save it. That, and then I'm just sharing this thing with you. Okay, just go for it. Okay, just go for it, and if you get any kind of doubts over, please do ask. Could you please share the collab link or shared by presenter? Which collab link? The morning collab link, right? So two collab links was there. This was for the sequential. Let me share this thing also. So three files total. Okay. The first was Simple one just for understanding the steps. Okay, second one was for the sequential, this one for the sequential, and third one is on Kaggle for the functional. Okay, so this is a complete ANN thing that we did today, right? So go to it, and if you're having any doubts to ask, you can open to your doubts. I will just try to sort it out, right? Okay, so three files that I used, I have shared. Okay, there is no data file that I have used. Okay, so that's why I'm not sharing in data file. Okay, the data that I am using is directly over the Kaggle, so I coded directly over Kaggle, right? So that's why there is no data file. I'm using GPU. After my job is done, I will stop GPU because in a single week there is around 30 hours of GPU that I can use. Okay, there is a limitation. So if your job is done, then you can stop the GPU so that your quota of GPU can remain with you, because obviously using GPU in my system, it will cost too much. I have to made a kind of investment. I have to purchase GPU, then I have to use GPU in my system, so that is not good. And for using this kind of data, again GPU helps a lot. Otherwise, while extracting the feature only, like we were extracting the feature with 70 cross 70, that is 4900 features, right? So while working with 4900 features, if GPU will not be there, it will take, like, while extracting feature only, it will take 15 minutes of time. And while training model, I don't know, it will take half an hour of time while training the model. Okay, without the help of GPU, if you try to train the model, it will take almost half an hour of time, because you can see how many learning parameters are there. The learning parameters are above 10 lakhs, right? What is this? This is a learning parameter when we skipped two hidden layers. Okay, when we are using some hidden layers, then total 10 lakh, more than 10 lakh learning parameters are there, right? So that's why it will take like more than 1 million learning parameters, more than 1 million weights. That's why GPU is very important while we are working with these kind of things, right? Thank you. Thanks a lot. Thanks, Miss Mohana. Thanks a lot. Now it's your turn. If you want to ask anything, you want to discuss something, you can just ask. Otherwise, we can wind up. So I hope you understood how can we tune. Okay, how important role a learning rate plays. Okay, how important is this particular dropout and all. Okay, how can we create sequential model, how can we create functional model. Okay, just try with some more use cases. There are a lot many things are there that you are going to learn further. Okay, try with some more use cases. There are certain more things that we will learn. Try to one more thing that you should go through, that is known as your um, confusion matrix and all, right? Confusion, please do go through, please do in further sessions, do go through confusion matrix, because confusion matrix is very important while we go for a kind of a error evaluation. Okay, just consider a case where you are having a sample size. There are two sample. Okay, there are two types of category: category 1 A, category 2 B. Okay, so just suppose consider a case. Okay, okay, I'm telling you why it is important. Just consider a case: you are having two category, category A and category B. Okay, so category A is basically the number of sample of category A you are having is 100, and category B you are having a sample 10, and then you trained your model. So when you train your model and you calculate the accuracy, you will get a very high accuracy, around 98-97% accuracy you will get. Okay, but this accuracy is of no use, because it is a highly, it is highly unbalanced data. Correct, that means in future, if B, it got just 10 value of B, that means suppose if these all 10 value of B is, it is predicting wrong only. Suppose it predicted all these 10 value of B wrong, then only the accuracy is 90%, isn't it? Then also the accuracy is 90%. That means it predicted all B value wrong, but accuracy is what, 90%, right? So that's how it is. Not just accuracy helps us in evaluating the model. That's why I'm saying, while you are going for the further things in the error evaluation, there is a concept called confusion matrix, right? Do have a read over confusion matrix, the like how confusion matrix work and all, to evaluate the process and all. Okay, and try with some more different data sets. Okay, there is so many things that you are going to learn. Okay, so deploy the or you apply the things that you learned today for the further processing scenario. That's it from my side. Okay, so unbalanced data sets will help you. Yeah, please, anyone wants to tell something? Thank you everyone. That's great. That's it. Thank you. Thanks a lot, Mr. Imran.
Thank you, Vipul Kumar.
Yeah.
So, on behalf of all the participants and on behalf of all the organizing team, I take this opportunity to thank Mr. Vipul Kumar, corporate trainer and CTO, Digilink Tech Club, for accepting
Right,
our request and for provided the in-depth knowledge in convolution neural network with the
right,
presentation and hands-on session with the different use cases. Thank you.
right. Thank you. Thanks everyone. Good luck for your kind of things that you are going to learn further. Thanks a lot. Shall I sign off?
Yeah. You can say.
Okay. Thank you.
So I also thankful to all the participants. Feedback link is shared in the chat window. All are requested to kindly share your feedback.